All right, so I'll start with common names of ether. So we use this common name only for small ethers. This is like the old system when we don't have an IUPAC yet. Okay, so to do that, we just look at the substituent on the oxygen and just call them a substituent. For example, the first one right here on the left side is an ethyl group. On the right side, we have a methyl group. So we're gonna go ethyl, methyl, and then ether. That's it. Super simple there. All right. Notice that is it a common name? Got space, right? Not IUPAC name. IUPAC name never have space unless for some there's a reason why they have space, but most of it no. Okay, this is common name. You can it's common like your nickname. You can write whatever you want. You can go like for example, some people name Elizabeth. She can go by Liz. She can go by Ali. She can go. It's just a lot of it, right? So I mean, you can do whatever you want with the common names. And next one, what we got? So on the left side, we have a third butyl group. On the right side, remember what do we call this? Benzyl, phenyl. Phenyl, we call phenyl, not benzyl. Benzyl is the benzene ring plus one carbon. Okay, this is phenyl. So we have third, so the B comes before P, so third butyl, phenyl, ether, space. Okay. What we got on the right side right here, so we have ethyl and ethyl. In this case, we don't go ethyl ether. We go diethyl ether. You can guess, man. This is not that not super difficult. Okay. All right. The systematic name. All right. IUPAC view the ether groups as a substituent called alkoxy group. So the alkyl group and the oxygen, so they call alkoxy, like methoxy, ethoxy, phenoxy from the phenyl ring and the oxygen. So and the rest gonna be the look for a parent chain, which is the longest chain, just like alkane. Let's take a look. Look at for the longest chain. This guy's a substituent, all right? So longest chain is a hexane. It's a parent chain. We have this group right here. That's a substituent, an ethyl, and oxygen. So we call it ethoxy. Okay. So in this one, going to be ethoxy group as a substituent by bond to position 1 of the hexane. So we go 1 ethoxy, hexane. That's it. All right. This one, find the parent chain first. Who's the parent chain? Benzene ring. Okay, that's your parent chain. Oh, by the way, so in IUPAC there's no space, no space at all, right? So for common name, so we go ethyl, hexyl, ether. You can do that too. Yeah, for small ether you can, but for larger ether you cannot use a common name. You will see why. Okay, this one, so we got phenyl. Right. Also the benzene ring, that's your parent chain. And we got methoxy group, that's a substituent. So how do we call it? We go 1 methoxy, benzene. That's it. Super simple there. Okay. The common names are going to be methyl, M before P, so methyl, phenyl, ether. All right. All right. So let's do this together. So first of all, you cannot use common name for sure. How are you going to call this? This is isopropyl, of course, but you can't use common name to call this substituent on the left of the oxygen. So this one we have to go to the IUPAC name. Okay, so find the parent chain first. Who's the parent chain? The highest number of carbon, of course. This guy right here, the longest chain, so 5 carbon, and the substituent right there. So we're gonna go. Well, we have to number them then. So you can do, let's say, do 1 up. Just ignore the stereo center for now. Okay, so 1, 2, and 3, 4, and 5. If you do this way, you're going to get 3 dichloro, 1, what's it? This is isopropyl, oxygen, isopropoxy. Yeah, 1 isopropoxy. And then your parent chain is cyclopentane. All right, so cyclopentane. Now, for some of you, hold on. What if I start counting from the left, from carbon to have chlorine? Now let's try that. 1, 2, 3, 4, 5. All right. In this case, what are we gonna get? We're gonna get 1 dichloro. Now, don't forget that. 3 isopropoxy. Okay, isopropyl and oxygen, isopropoxy, and then 5 member ring right here. So we go cyclopentane. All right. Which one's better? Of course, we get 1 right here. So we take this one, the lowest number possible. Okay. All right. Now, the last thing, so it's going to be the stereochemistry of this carbon. All right. Oxygen is number one. Carbon, same thing. Next one, carbon with chlorine, carbon with hydrogen, totally, carbon with chlorine. So 2 and 3. Hydrogen, point to the back, so we're good. All right. 1, 2, and 3 looks like R, so we get an R. So 3R, 1 dichloro, 3 isopropoxy, cyclopentane. Right. In the case that there is only one stereochemistry in the compound, you don't need to add 3 right here. You don't need to. Okay. Yeah, we usually omit 1, but yeah, if you just add it, it's fine. All right. Come down here. So we got let's see, 1, 2, 3, 4, 5. That's your parent chain. Okay. So how do we name it? We have an ethoxy group at position 1. So we go 1 ethoxy. All right, and your parent chain is cyclopentene. So we go at alkene at position 1 and 2, so 1. So we go cyclopent 1-ene or 1 cyclopentene, whatever works. Okay. All right, let's move on to the property of ether.